I've got a chapter, but before that I want to show you a new project because Anna Bantis, one of my students, told me about a pay training product, which is very nice. So let me get my, here's this class, and I think I put a link to it in this class, but I know I've got a link to it on my 140 class. There is a training product called Pen Tester Lab, and what is going on with my network? Right. At this moment, the network seems to die.
Yeah, mine is too.
Well, let me try the guest network. I often find that when the staff network fails, the guest network works better. It's answering that question, popping up with a question anyway, which is good. Yeah, usually the staff network dies pretty often and the guest network is better. It's supposedly throttled, but anyway. So this product that I got is called, Pen Tester Lab. This thing costs $20 a month or like $33 for 3 months. And it is very good. They have a bunch of attacks and they have training videos and training instructions. So they totally lead you through doing them. And I was able to do a lot of stuff here that was too irritating for me to set up. And it inspired me to make my own SAML project. So that's the first thing I want to show you. They have a couple SAML projects here and I said, how hard is it to set up SAML? It turned out to be much harder than I thought. I spent the entire week of spring break setting up this one project. But now I've gotten pretty good at it. I ended up setting SAML like 6 times up to where I can set it up pretty fast now. And earlier today, I actually got a version of SAML running. It's 8 years out of date, hoping it would have fun vulnerabilities, but it doesn't seem to, but maybe. But in the meantime, I have a version of SAML that I broke because there's a product called SAML PHP. Simple SAML PHP, which is apparently quite popular, and it's all in PHP, so it's really very easy to read the code and modify it. So I was able to install that and get it working and then break it. So we have something fun to hack into. So this is the last project in this class, the official project, this SAML project, which I'm very happy with. This turned out to be pretty easy and pretty important. So you have to have burp going through a browser, of course, like you do for pretty much everything in this course. And let's talk about SAML. We mentioned it in the class, in the lectures before, so I made a server, SAML LOL, here. Okay, so this is a challenge. Right now you're not logged in, so the kitten is asleep. You can log in, and there are a couple of accounts here. User 1 PWD and user 2 PWD, just as demonstration accounts, so you can see the login process. So if you log in, if this is not going to work, I'm going to be annoyed and I'll have to show it to you next week, which is rude. What is this nonsense? Perhaps I broke my identity provider when I was trying. I don't think I was changing anything about my identity provider.
I tried it this afternoon, it worked.
I know. I wonder if it's something to do with the network. I gave up, what time in the afternoon? I gave up about 2.
Like 3 or 4.
Well, then it should still be working. How rude. Unless, and I didn't think anybody could hack it. So let's see if the winners page is up. The winners page is up. Well, that's something. There's the project, which tells you what to do. But if the login page will not load, then I'm annoyed. Let's see if I can load it from here, but maybe I'm probably going to have to wait till next week to show you that one then, because it seems to be failing on me. Let's see if my burp is up, the proxy is running, it's not intercepting. Okay, log in, I say, and it won't load. All right. Well, that's annoying. I must have broken it. Okay, so forget that. I'll show it to you next time. It's no fun if I can't demonstrate it. Anyway, we'll just carry on with the normal stuff. You got several weeks to do that project anyway. All right, so today is supposed to be what chapter? Chapter 10? Yeah, backend components. All right, let me get it up. We'll stick with that. If my other thing is not going to work, well then phooey. Last time I tried to demonstrate it, it didn't work for another reason. It's a new project. It's taken me a little while to get the bugs out. Anyway, so backend components, this is actually the way we started mostly in this class. This is talking about command injection and things like that, which is the first project because it's easier. If they had asked me, I would have rearranged the chapters in the book. But anyway, so the backend components are the parts of the operating system that run on the server that are not directly servicing you, and you can attack them too, of course. If you can inject operating system commands, you can then copy files, you know, make network connections, view the network processes, and so on. And the most common reason, as we said at the beginning of the class, that this happens is because you have a programmer that is too lazy to actually learn how to do the whole job in one language. And instead of that, they just create a command for another language and then pass that command off to a command parser. And so here, they build a command here, which is du, which is I think it shows disk usage. And then this is going to show you the size of PHP files. And then it just executes that command with the operating system, which is what this thing does, I think, with the backticks. So they take input from the user, incorporate it with other text, build a command, and execute it. And of course, if the user knows how to put in meta characters like semicolon and ampersand and pipe, they can add extra commands that were not intended by the developer. And you all did this with the ping form and so on. So the intention, as used, the intention of it is you can get a directory of files and folders, but if you just use a semicolon or something else, a pipe here, then you can do the directory and then feed it as input to another command, which is one way to do. Input won't do anything, but it's another way to run a different command, and now he can dump out the password file. The password file is not important. It is just something that people typically do to prove that you have local file inclusion. This is a file that is world readable on every Linux system. So if you're going to see if you have the ability to traverse directories and see a file, loading that file is what you usually do to prove that you have that right. And this has, of course, has happened in real products many times. ESP OpenView is one of many others that just had this kind of vulnerability. There was a OVPL file with a node, and you could just put a pipe and another command there because that was just used as the path of some Linux command. ASP had the same thing on Windows systems. All you had, there's a directory here, C directory, Command C will execute the command directory, and then it puts a directory name here, and that came from the user. So again, you can just put a meta character in like a semicolon and add more parts to it and do command injection on Windows. This is an easy way to write programs and a very dangerous way. So there's a function to print the contents of a directory on a Windows machine, and of course you can trick it into doing the wrong thing here, where it does ipconfig after it does directory. So he fed in the directory name ampersand ipconfig. So it does some directory and then it does ipconfig, and you could put anything there. So that's again, PHP is what we did in this class, the very common one. You have something at the end that is used in some kind of command. Typically they use an eval command to do this. This is I actually wrote PHP that uses the direct OS system call, which is like that thing of backticks. But the thing that is perhaps more common and perhaps slightly less obviously insane is to use the eval command. Eval is notorious as being insecure, like string copy in C. You take this data and you evaluate it as a command. So if it's controlled by the user, you just gave them a command shell essentially, and that's what happens. All right, so if you want to find these things, the question is, does any of the user-controlled parameters end up in a command? And they all depend on special characters, like semicolon and ampersand and pipe, and backtick is another one. So trying to inject those characters and see what results is a good way to find it. One thing that I've learned from that pen tester training site that I mentioned, which is very nice, is most of the time you cannot see the results of your commands. This is by the most common situation because most websites, now there are a few artificially contrived examples, like it prints out a directory from the file name you put in, but usually the file name you put in is used for some other purpose. And when you change it to something with unexpected output, that output is fed into some program and not just printed out where you can see it. So in these examples, when you learn it there, what's very common is when your command injection works, you will get a 500 error. As the server says, the server seems to have crashed. It stopped, it's not handing out the expected output because your command worked, and now it's doing something unexpected at the other end, and you can't directly see the result. So you have to get used to that. Most of the time it's a blind injection. Like we talked about blind SQL injection before, where you do not see the results directly, but you have to infer indirectly that your commands worked by composing something that's true and something that's false and adding something like a time delay, so that if it's true, some time delay thing will happen, and if it's not true, that thing won't happen, and then measure the time of response, that sort of thing. So you can use NSLOOKUP. NSLOOKUP is kind of fun, and this gets you into the world of malicious DNS servers, which is DNS rebinding attacks that Tavis Ormandy's gotten into. Tavis Ormandy is a Google researcher, he's awesome, and he gets on one track, and he spends a few years ripping a whole category of products apart. So he spent about the last 4 years ripping antivirus products apart and making them into garbage, just showing how much remember, he could totally take over your Mac right through the antivirus. It was bloody awesome. And then, now he's going into DNS rebinding attacks, where you have a product is written, so it has another uses services that are listening on 127.0.0.1 on the same machine. And ever since Vista, Microsoft Windows all by itself is listening on about 20 high-numbered ports on 127.0.0.1. So Microsoft loves to do this for some reason. To make one process on a machine talk to another process on the same machine, they send it to the network card and back. And that seems okay because you think 127.0.0.1 is only local, but it's not. All you have to do is change your domain name so it resolves to 127.0.0.1. And now, when it thinks it's talking to the web, it's talking to the other process on your machine. And he found a ton of vulnerabilities that way. This is, anyway, so that's what this is doing too. They're using NSLOOKUP to find a domain name, and when they go to the server and get the IP address, you can put something malicious in there, and if you might even be able to put a record there that will have a command in the resolution of the name, like a CNAME record or a text record or something. So that's one trick. Anyway, so in general, obviously you should not be creating commands in another language from the first language you're asking for it. This is how SQL injection happens. If you feel like you have to do that, then you should be aware that it's extremely dangerous and do something like whitelisting. Like there's really only 2 or 3 kinds of commands. Make sure that the thing only has a certain number of characters, try to limit it. But of course, that's very risky, very difficult. You're trying to enumerate all the badness. That is just a challenge to the hacker to think of some way to encode a semicolon with Unicode or something so it won't be stopped by your grep, but it will still have effect. And it turns out there's a lot of dirty tricks of that type to work. So you shouldn't be passing user input into dynamic execution functions. If you think you have to do that, then you should really be filtering with whitelisting. The best thing is to have a list of some number of hard-coded commands to execute and choose them from a list of options, instead of directly taking any text and putting it in a command, which is just a kick me sign. But it's very common that people handle file paths. PHP encourages you to do this, where you put file equals file name. Instead of just browsing to files directly, you feed them into PHP functions. That's the way it's naturally used, and that leads to all the local file and remote file inclusion vulnerabilities. So path traversal is where you are able to use .. to move out of the folder where you are and somehow move into another folder. The simple one is where you do it right here in the URL, and almost no modern web server will fall for that. They've all pretty much learned the hard way from the days of Windows NT, which was vulnerable to that, that's too horrible. But if you have some other reference to a file name, you can often put .. or .. in there and traverse up to where you don't belong. And this win.ini file is a file that back in the days of Windows XP and earlier, that file was on every Windows machine and it was world readable. It's not very important, and it's not even there anymore in modern versions of Windows, but it's like its password. It's a file to demonstrate that you have the ability to read files that you shouldn't be reading. So if you write to files, you might be able to do this. This, I think, is, in my limited experience, this is, I think, why PHP-based websites get hacked all the time. This is how mine got hacked 2 or 3 times, other teachers got hacked. I know in practice, if you base a website on PHP, within a year or 2, you will get hacked. And I think it's because if you make a website, before long, you have to have some way for the user to put a file up there. Upload an image, put up a chat comment, put something that goes into a log. After a while, you do that, and frequently you make a mistake, and now it's able to write somewhere else, and then you get hacked. They just write to a local file which redirects all your web traffic, or they deface your web page. Plenty of things can go wrong. And this is what happened to me a couple times. I just copied. I had a file on my machine that would put /dot headlines in a box before there was Twitter, so you could see current headlines. And it turns out, and then it didn't work very well, so I put it in a test mode where it would take a hidden parameter and write there. And then I forgot to turn that off later, so students found it and they were able to move that around and hack my website. It was bloody awesome. Anyway, so that's the game. If you can write on the machine, of course, you can overwrite config files, system binaries, all sorts of good things. And so if you want to prevent this stuff, FileMon, we were just talking about before class starts, was designed for this. You monitor, it gives you a readable entry in your intrusion detection systems of when people are doing file writes, and now if you do the right query in something like Splunk, you can spot it. Spot that somebody is writing to a system file which they shouldn't be. On Linux, you got ltrace, strace, and the one we used in the projects here was Tripwire, all of which do essentially the same thing. They give you an ability to watch and see what's happening in Solaris, if anybody's using that, as something called Truss. There are tools available if you use them, to monitor with what is happening to your file system and give you some ability to warn it. Path Traversal, if you want to find it, what he recommends is run one of those tools. First, install the software on a test system that you totally control. Now run one of those tools like Procmon, or FileMon, monitoring Sysmon, monitoring every write, and set it to just dump all that in a file, and now inject the same name in everything automatically with a script, like in burp, and then look for this name appearing in any file being written. That's a pretty good way to do it. Then you can run an automatic spider sort of attack to put this in every parameter it finds everywhere. And if any of them actually write into a file name, you'll see that. So that's a pretty good way to detect it. So here's a successful path traversal attack. There's a file name here who has .. / windows.ini, and that, I guess, is what's in the win.ini file. I haven't looked in one in years. But anyway, it's just some junk left over from MS-DOS is what it is. Back before there was a registry. Try the / and the /. On Linux machines, they have completely different meaning, but on a Windows machine, they're typically treated the same. So try URL encoding. Is %2e / another thing. You'll see it a lot in that pen tester lab, which I highly recommend. Oh, by the way, of course, it's worth extra credit if you do the pen tester lab. Let me know how far you get. I got the white badge, which is a start. Anyway, the double encoding is very good, where instead of putting %2e, you put %252e. And the pen tester lab finally explained something I was wondering. There was a version of IIS that actually doubly decoded URL encoding. That was like version 3. That's gone and over. I said, why do things keep falling for this? And they explained it. People like to use Tomcat. Normally, if you have simple web server, you run Apache. But whenever I go to the wall of sheep at DEF CON, everything is programmed in Tomcat. All the big guys use Tomcat because Tomcat runs in Java, and you can run it on a giant server cluster and scale it out to a ton of machines. So huge things like Amazon are running on Tomcat. But Tomcat is unsafe. Tomcat won't even run on port 80 by default, because you're not supposed to connect it directly to the internet. What you have, you run it on 8080, and then you have a proxy, an Apache proxying to Tomcat. So it is very common that your data passes through 2 web servers. That is the normal way to set it up. First it goes to Apache, then Apache proxies it to Tomcat. And each one of them decodes the URL. So it does get doubly decoded. So that's a good reason. Another thing that might happen is you might pass through some kind of intrusion detection system or firewall or proxy server in the front that decodes it. That's why it's actually quite common that stuff gets decoded twice. It would seem like a stupid mistake, but you're passing through many machines. So it could happen. Anyway, 16-bit Unicode is here, where you %u and then 4 hex characters. There's even longer versions of Unicode too. Here's WRL encoding. Here's overlong UTF Unicode encoding with even more than 16 bits. And like I say, these are all ways to encode special characters so that the filters might miss them. And yet they might be decoded and understood at the final end as still meta characters that have the desired effect. Here's another trick, of course, if they use filtering, we talked about this before, if they try to stop .. then you just create something which after removing a .. turns into .. and that will often get through if they just have one round of grep. These will all turn into a path traversal after they've been supposedly cleaned. That's why, I'm amazed that people do this. They clean something and then they use it. Why don't you, if there's anything bad in there, just reject it. Make them send you something that's not poison. Don't clean it and then use it as if it's okay now. But a lot of systems do. I don't really understand why. I suppose it's considered more usable and more friendly. But I don't know. It just seems to be asking for it for me. That's why when people invented HTML, people got really, really angry. HTML is real garbage. In the old days, there were languages like Fortran and C. And if you make any mistake, like one semicolon, it will just stop and say, I'm not running this crap, fix it, fix your syntax error. But HTML will just let you make mistakes and it will just guess at what you probably meant and show it to you. And when I heard that, I said, oh, that can't be right. And I said, oh, that's what it does. And it means browsers are really big, and it means the same page will look different in different browsers. And I said, well, that's opening a huge can of worms. And people said, yeah, it sure is, but that's the way it is. And people got used to it now. So the web is all full of poorly written HTML, which they expect you to render. So you're down, that started the tradition on the web of taking crap and filtering it and then using it anyway, which is awful. Anyway, that's where we are. Null characters are also there. You can insert null characters, and if you're lucky, the null character will terminate the string for the filtering box, but it will not terminate the string on the server. So again, you find a way to sneak the forbidden characters past the filter. I know the first generation of, I saw a talk by Joe McRae years ago, maybe 4 or 5 years ago, and he said at that time, web application firewalls were so stupid that you could just put like double spaces between the characters in a SQL injection attack and they would go through. You could put uppercase and lowercase mixed. You could just you could URL encode a few characters and not all of them. It was just the smallest variation, because all it was doing was grep against a list of like 100 common SQL injections. Sure. And all you had to do was change anything so it didn't exactly match one of the top 100 things, and through it goes. I hope they've gotten better since then. I assume the expensive stuff has gotten better anyway. So you might find read access vulnerabilities. And let me just check and see where my, see if I've got my slides coming up. I do. Okay, I thought I might have the wrong deck, but I do not. Okay, good. All right, I do have the Kahoot coming. All right, so if you can read, you might be able to read the password files. Now, they've been onto this for decades, so the password files are getting harder to reach, and when you get there, they hopefully have just hashed junk. But apps typically are not that smart. I was at the last DEF CON talking about all the Android apps that just store your password in plain text or stupidly poorly encrypted somewhere obvious. There's a ton of them. I remember one of the funniest ones was the Nessus phone scanner. They wrote an Android app, and the Android app puts your password in plain text on the SIM card. It was awesome, and they were so embarrassed they took it down and they don't have an app anymore. It's like, that was really shameful. But anyway, so McAfee Enterprise Edition did that like a year ago. They had a vulnerability report that he took if you put it on a domain, it would take the domain administrator password and put it in plain text all over everywhere so people could find it. Anyway, might config files, might include files. Unfortunately, a lot of programmers put credentials inside the source file of their apps. Hard-coded SQL passwords, hard-coded Amazon private keys, and so on. And so if you can see the files, you can often find secrets in there. Your databases, the source code for things, and log files. Log files often contain confidential information. You've got kind of a nasty conflict there. You want to include a lot in the logs, you can debug stuff, but then you've created something that's dangerous when people steal it. Yeah.
You know, I work on a couple, integrations, and yeah, there's always the point that the app, when you need to connect the app to certain instances, there's always these ID, although they're not admin, there's always, you have to set additional IDs and credentials. And I'm always curious because obviously, they couldn't answer. It's like, how well are these being encrypted and where is being stored?
Yeah. Well, this is a big tough one. This is what Microsoft always said. They didn't care about things like pass the hash, because you had to gain administrator rights to steal it in the first place, and after that it's all over. But it's not really all over, because getting administrator right on a workstation that somebody is surfing the web and clicking links on is a lot different than getting administrator rights on the domain controller, and that's what pass the hash lets you do. So it's eventually they had to do something about it. But people always have lame excuses whenever you point out their security weaknesses, but it's hard to think about defense in depth. So they're trying to get the job done. They think as long as there's some control in there, you're okay, like Amazon. People are stealing my Amazon credit card. Amazon thinks it's okay because they have some degree of controls in there. I'm sure, to be fair, they might have done an analysis of how many dollars per year they're losing from having it this way and how many dollars per year they're gaining from people being able to use simpler passwords. But I don't know, the whole rest of the world has gone the other way. They're the outliers. Anyway, if you get write access, you can then create scripts, create them in a startup folder. They'll happen when that user logs in or every time that user executes a command. You can put scripts right in the web server. There's what we typically do with PHP shell injection. You upload a script and then you run it yourself by just surfing to it. That's another good way to do it. So if you want to prevent all this nonsense, you shouldn't be using user-controlled data directly in anything that goes in the file system. If you must let the user do something like choose a file name, then you should let them choose from a list of known good inputs or characters or something. We talked about this. And the next slide has more defenses. After you finish all the decoding and then check for all this stuff, but make sure there isn't some later translation step after your check, or they're gonna be able to sneak stuff through. And like I say, it would really be a good idea to just reject anything that you aren't sure is good, instead of trying to clean it and then trust it, which is, again, just asking for it. The best thing would be to force the file type to be from a list of known good file types so they don't get to put in their own. Make sure that the file system actually is okay and that it exists in the expected directory. If you're referring to a file name, there's a Java function called getCanonicalPath that you can use to check the path of a file before you use it. There's another one in ASP. Those would be good things to do. And if you really were serious about this, run your app in a chroot jail. This is the old-fashioned solution. Before there was virtual machines and containers, there was chroot. You'd set up a chroot file system, and now the entire application can only stay in the chroot. The root is now mapped to, var, app, and then you put whatever commands it needs in the chroot jail, and the other commands are not there. The real system configuration there is not there. This was what used to happen decades ago before there were virtual machines that accomplish essentially the same thing. Your app is trapped in a limited file system, and it can't get out. Although there are some escape attacks to chroot jails, just like there are for virtual machines. They're not that common, and this is considered quite good. You can do it in Windows by mapping a drive letter to a folder, and then referring to everything by that drive letter. It has the same effect. Now, everything that app does is stuck inside that jail, unless, of course, you have some hole that they can get out, but still, it's pretty good.
Yeah, if you try to get to root, it's just going to get to the root of the root of the.
That's the idea. Yeah, you're trapped. And now you do it with a real physical machine, a real virtual machine. The same thing. Put it in a VM, and then most of the time they can't get out of the VM.
Yeah.
And you put your goodies somewhere else, like in a different VM. Include files are very popular. This is the whole point of making coding of libraries and everything. You should keep reusing the same file in app after app. And that's fine. PHP allows a lot of include files. They also allow you to include them from remote servers, which is, again, something you might want to do, but it gets pretty risky. So here's a app that has a country code. You put in the parameter, and that might be fine, but here's how it does it. It includes country.php without further sanitization. So if you put in a country of a URL to an evil server, then it will load that file from an unexpected server, not the local server, because the developer didn't think of removing // from the file name and so on. This is remote file inclusion. Local file inclusion is when you don't go to another server, you just refer to some resource on this machine, which is other than the expected one. And you can have get to files you shouldn't get to. So here's how you find it. Insert a URL on a web server you control, and then run your automatic process that injects it everywhere, and then look at your server log and see if it's fetching files from you. That would be a simple way to detect remote file inclusion. It's another way to do it. You can also just make it go to a non-existent IP address, so it will cause a time delay because it has to wait 5 or 10 seconds trying to resolve the domain name, and then you can just look for delay to tell you that it must have made an attempt to reach that server. So put in things in each parameter: a known executable, a known static resource, sensitive resources, traversal to another folder. These are all things that might work, and you can write scripts that will try it in every parameter until you find the one that's vulnerable. I would imagine that professional vuln scanners might do some of this, but I just know in practice they're not terribly effective. I wonder. You'd like to think they would do all this automatically as part of an SS scan or something, and I do not know how true that is. Let me start up Zoom for...
It must be old because it says iClicker on our version.
Oh, are the iClickers on there?
Yeah, that's what the graphic is. When you get to that point, it says iClicker.
Well, yeah, it might even have the questions after that, in which case it kind of compromises the perfection of my system. That's part of why these things are extra credit.
Oh, yeah.
There's a couple of them where I forgot and published the wrong version. That must be one of them. So they might be the same questions, too. You might be able to pull ahead that way. There are weaknesses in my system. That's why the Cahoots are all extra credit. Because even when I had them with iClickers, there were weaknesses. So 129S, Chapter 10A is here. And we'll see if I just reused those questions or not. I don't remember. Probably I did. If they looked good, I probably just kept using them. So, what vulnerability allows you to add malware from a different server to the web page? That's file inclusion, in particular remote file inclusion. All right, so what defense puts the web server in a restricted file system? That should have just been procmon, and it got two things rammed together there, but anyway, chroot is the answer. All right. So what defense detects file system modifications? That's Procmon, okay. And what vuln do you get if you use eval? Okay, that's command injection, good. All right, let me record these winners and then I want to point you to the scores. Ward F, right at the top are the scores. This number is the last 4 numbers of your student ID, and you'll find over on the right your midterm grade and how it was calculated. I only included everything that was due up to a couple weeks ago, so everything is reasonably in there. And so this is how I calculated the midterm grade, and since it's, I'm pleased to see a lot of people are way beyond that. This is your total for the whole class, and the color tells you if you've already won. The people with green have already got an A, the people with yellow have already got a B, and you'll see this down here. You can hear the delay in somebody's, that's the score for the whole class there. So some people are pulling ahead and they've already done enough work to get an A. They don't need to do any more. You do not need to take the final or anything if you do enough extra credit to make up for it, and some of these people have. But if you're going at the normal pace, then you'd probably just have an A on the midterm, but you don't have an A in the whole course yet. Anyway, that should be going. I saw a chat message. Let me see what's in the chat message.
So,
Ray, yeah, Ray, I figured that, yeah.
550 is the total?
What's 5? The total, yeah, total is 550.
Okay.
Yeah. I decided that today because now I know all the projects. I didn't know it earlier, but now they've written the last project, although it's not working right now, but anyway. In fact, all right. So we got another bit to go through, but I've set that whole thing up like 6 times, so I've gotten very practiced at it. So I'll be able to fix it when I have enough time to go through it carefully. Such is life. But anyway, one result of this week setting up that project is it reminded me of something I should tell you, which is when you find a vulnerability, don't just scream and abuse people for having their servers set up wrong, because it's really, really a pain to set up servers. And there's reasons why you have to do stupid things just to get to the end. Almost all my servers are set up wrong. So have some mercy on the poor developers. It's not just that they're idiots, they've got a hard job. Anyway. So, all right, so here's another form of injection, XML external entities. This is kind of like PHP include files, but it works like this. There are a lot of XML-based languages in use on the web, and they're used a lot now in AJAX. AJAX originally stood for Active JavaScript and XML or something, Applied JavaScript or something like that, and now it has become an independent thing going beyond that, but it does use a lot of XML, and the point of this is it used to be you'd have to load a whole web page from the server. And then we wanted cool things like Google Maps, where you can drag it to the right with the mouse, and it just loads a little bit, like a 1/4 inch on the left, and then another 1/4 inch on the left. So it asks for, give me just a little data, just a little more data. That's AJAX doing that. And that's awesome. So what you do is the client will send a request up here, a post that will then search for something. You send it like a query. I'm searching for something, send me the response to that. And this is what your apps are doing on your phone too. They're sending these little requests for just a little data, not big whole web pages with junk you don't need in them. So the server sends you a response. And now if you have, this is like the kind of pages that have cross-site scripting. If it repeats what you said in the response, so I searched for, and here it said no results found for that expression. Now, this means you can control the response, and there's a whole series of attacks. One of the ones I learned years ago from an old WebGoat product put out by OWASP was HTTP response splitting. You can put HTTP headers in something that's going to be echoed back by the server and cause your browser to see 2 HTTP responses instead of 1. So you can sometimes trick the browser into showing you something it shouldn't have shown you. And so in this case, what we're going to do, this is kind of like the bash vulnerability, shell shock. We're going to create a thing called an XML external entity, which is like a stored function that will automatically run. So these things are entity references. You can declare a variable in XML and it persists like an environment variable and affects future pages. And this is how you do it. You define this thing called entity test ref, and it has a value. Now that would just be the normal kind of environment variable. It just stores a value, but you can actually declare entities that refer to files and even URLs. So now we've defined an entity called XXE that refers to a Windows file. And now we're going to do searching for XXE, and it's going to print your search for XXE didn't find anything, but because we put the ampersand before it, it's going to interpret the XXE as a function and run it. So we were able to define a function and run the function all with this request. And now the reply says no results found for expression, and here's the contents of that file. So it amounts to the same thing as like a PHP shell, where you can put up commands and it will execute those commands for you, and it's pretty awesome. So here's another one. You can connect to an email server, and well, you can send an XXE that will connect to an email server. So you can use XXE to pivot from one machine to other machines in the network. For the email server, it's probably not accessible directly from the outside, but you can do it this way. So you can use a lot. This uses your application as a proxy to get inside the machine. You can send it to other back-end applications, scan ports, harvest banners. You can create denial of service conditions. This will just create an endless list of random numbers. You could upload a fork bomb. Fork bomb is just a few punctuation marks that frees any Unix server because it causes an endless loop of copying this this running process to more and more copies of the same running process until you run out of memory, and so on. There's always the famous rm-rf star. There's lots of Unix commands like format C on Windows that you should never run, and you could do them, right? You can also inject into SOAP services. It's another XML-based format. So here's a banking app. I send a post, and it's trying to do a funds transfer, so it's going to go from this account in that amount to that account. And that sounds fine, but the problem is so it's going to go between a couple of different back-end servers. What's going to happen is it's going to ask at the other end, is there enough money? So it's going to send this request inside the machine, looking for the amounts and the account numbers that came from me. So what you do is you can send a request with injected XML and HTML comment tags. So I send in the red stuff. This is what I put in for amount. This should look like SQL injection to you. I'm supposed to only be putting in an amount, but I use less than and greater than signs, so I add tags in the amount. And if I craft it carefully, it now is formatted. This is the end of the amount. Now I have cleared fund equals true. So we'll interpret this request as one that has already been through the authorization process and send it to an account. And then I'm going to comment out that part of the account. So it will now, I'm controlling the account it goes to, and I'm showing it's already been approved. So that's pretty cute. Here's the resulting SOAP message that will go out there and have the result. You know, the same kind of thing. Once I can inject meta characters, I can mess with the code. Just like SQL injection, and just like SQL injection, at first it's sort of irritating and confusing, and you have to learn the syntax. You have to get these little injected characters just right to do the nasty stuff. But, you know, it's not any harder really than SQL injection. You just have to get used to it. Here's one.
Do that in burp or something? Because
yeah,
they would do a lot of checking on the client end to make sure you didn't put those characters in. So
yes, you would like to think so. Yeah, they probably would try to block you for doing that, but you do it in burp on the way out. So if they don't check it again on the server, they're hosed. So here's another one. The other thing you could do is you could put in the stuff you want. Remember, we had a lot of SQL injections that ended in a comment to just get rid of the rest of the line so you didn't have to bother closing it. You can do that here, and if you do have an opening comment at the end of your injection, it's going to comment out God knows how much code until it hits the next comment from the developer to end it. So this will do strange breaking of the page. So if you want to find this stuff, that would be a pretty good thing to just inject. Inject stuff that's going to be seen as the start of a comment. And now this would be an unmatched closing XML tag. So your injection is being filtered out. If it's not being filtered out, it will now have an error. The XML parser should throw an error for this. You're not allowed to have an unmatched. That's one thing to know. If you get an error, then do this. And if the error vanishes, that means it did understand your injected XML tag, and when it no longer broke the syntax, it was acceptable. So that means you know you are able to inject code. All right, you can also have second order SQL injection. Remember this from previous chapter where this is what the cartoon is, where you name your kid Bobby apostrophe semicolon drop tables, And when they use the name later, there's a SQL injection. So you can do that here. You can put these values in a database, inject them as account numbers or names or something, and then when they're used later, it'll cause XML errors. So inject that into one parameter, that into another parameter. That will remove whole blocks of code. So if you're lucky, you'll take away the code that sanitizes data or whatever, the code that checks to see if you really have enough money in your account before giving you the cash or anything like that. So if you want to prevent this stuff, you obviously want to block all these meta characters or properly encode them as ampersand, LT, semicolon, and so on, so they will not be interpreted as meta characters at the other end. And there's some more fun stuff you can do here. HTTP redirection and parameter injection, which leads to one form is parameter pollution, the simplest kind. So you've got a user-controlled input in a URL. And this is retrieved by a backend request, so the user controls this loc. I specify the location, and so I put the name of some URL there. And it's going to view this page, and I'm able to control the URL. So what I can do is I can feed in IP addresses, local IP addresses, and I can now start connecting to local servers on specified ports with this request, which is very much like what Vincent Taviso did. He set his DNS server to resolve things to 127.0.0.1, so when his app tells you to go to another part of his app, it's actually probing your internal network. And that's what this is doing. They thought I was viewing files on their server. I'm doing a port scan of their network with this thing now. So again, your app can be used as a proxy to connect on the internal network or to connect back to 127.0.0.1 to the other listening ports on the same machine. And this gives you a door through which you may be able to inject other attacks. And then there's parameter injection. This is where you get to control parameters down here. So here we've got a post going up to the server, the same thing as before, from account, amount, to account, submit. And it's going to be forwarded up on the server, again, containing the data that I gave it. It's going to go between servers up there. So the front-end server wouldn't have to bother sending it to another server to ask if you have the money, if it had the clearest fund equal true in it, like the one we saw before. So with this response, if I can trick it into doing this, and having thinking the cleared fund is there, it will go. And here I have these special characters, %26 and %3D there. If I can inject meta characters into the number, I can make it think it's already cleared me. And there's the result. That will send a post that says it's already cleared. So this kind of thing, this is like adding admin equals 1 to your request. Maybe it'll think you're the administrator. And parameter pollution is also quite similar. It turns out that there are no rules of how to handle it when there are two copies of the same parameter in an HTTP request. No, it's just not included in the RFC. So it has random, unpredictable behavior. So if you can instruct a second copy of a parameter, any of these things might happen. Only the first one is used, the second one is ignored, only the second one used, the two are combined in some way, and the sum is used. Any of these things might happen. It might turn it into an array instead of a simple data object that includes all the values. So here's the original request, from this account to this account, cleared fund equals false to that account. So now I just add another parameter, from account, then I add cleared funds equal true here in that number. Then there's a cleared funds equals true here, and there's a cleared fund equals false somewhere else. The one I injected and the one the server put on there, and maybe it will understand the wrong one if I'm lucky. A lot of apps rewrite URLs. This is quite common. You can do it in your Apache and everywhere else where URLs are reinterpreted to map to other things. This is how simple SAML works. I think I've said it many times. So this is how REST-style parameters work, where things look like they're in the folder name, but they're interpreted as parameters at the other end. And of course, those rewrapping functions can be exploited. So here's a rule. Rewrite the request if it has capital letters and numbers from 3 to 9 and so on, then rewrite it with this format, this regular expression format. So that will change this request into this, user manager PHP mode view. This is how you do RESTful parameters. Pub user Marcus is actually, the name is Marcus, the mode is view, and I don't know where the pub went. But anyway, I think this is how it's picking things out of the path and turning them into parameters. That's what that rewrite does. This is how RESTful type parameters are injected. So what you do is you inject a special character, %26 here, and now it will change into this, mode equals view, name equals Marcus, and mode equals exit. You've now inserted another mode edit. So even if you're not authorized to edit files, you might now be approved to edit files because you put the parameter in your name, which was rewritten into a readable parameter. You know, all these are the same thing. You're taking something from the user, and the user gets to sneak meta characters into it. So you can, so apps typically send mail via SMTP. The one here did, as a matter of fact, when we ran the active scanner on the City College server a few years ago, it sent 10,000 emails with error messages containing data that we had injected to the server. And of course, there were other things on my mind at that time, but we probably could have exploited that in other ways. Anyway, so user supplied information is typically in there. That's the whole point of it. It has some kind of error. Some user sent this stuff right here. I didn't understand it. So here's a site feedback form. I've seen a lot of these, and they really look easily exploitable. So I'm sending a complaint about the site here. I often try to report vulnerabilities in these stupid forms, and then I feel like reporting vulnerabilities in the forms. So here we go. This will send that message. Confirm order page doesn't load. But what if I checked the email address, and then I put a %0A here for a carriage return, and I added a BCC here to all kinds of other people. Now I can send spam to third parties from their server because they didn't filter out that character. And if you know HTTP, I mean SMTP is like HTTP. The request is just plain text, carriage return delimited. So if you can insert this, it's going to be interpreted at the other end just like HTTP, just lines of text. So it will be fooled by that. And here's a feedback request. We'll create this conversation. Mail from here, receipt to, data from, the from to, this is the detail. From to and subject just show up on lines here. And if there was going to be BCC, it would just be another line there, just like another HTTP header. So it's perfectly fine. This one here is going to have subject. And in the subject, I put a %0D, %0AD, get to a new line. Then I put in foo, then I put in a couple more returns. Then I just make another mail from request here. Mail from here, something about Viagra to these people. So now I'm sending Viagra spam through their server. And that's the result. This is very much like HTTP response splitting. Now, they thought I was sending one email, but I turned it into 2 requests. And often, this is legal. Remember how you've done this, you took the 124, the Violent Python project, you do like 100 requests with the same TCP socket. Because as far as the server is concerned, it's just a long line of data. Here's one command, here's another command, here's another command, and it often doesn't pay attention to how they arrived, because that's stripped out. So I can just put 2 commands here in the same request, and it will just process them both. So now they wanted me to be able to write this, but I was able to write that and send spam through their server. So good, clean fun. So you find this stuff, of course, inject into every parameter, and try, Windows and Linux new lines and so on, that sort of thing. If you want to prevent this, then you should be validating the data. What else can you do? Emails should be checked to make sure that all you have in there is one email address with one @ sign and no new lines and all that jazz. Check for the meta characters. That's pretty much all you can do. All right, I think that's it. Let's see. Yep, so I got another one of these Kahoots, and that's it. I'll have to show you a SAML next time. I gotta log into my Kahoots. In fact, I have to restart the Zoom because my machine appeared to crash and I restarted it. Okay, we're gonna set the same value twice. Okay, that's HTTP parameter pollution, that's what they call it. All right, which attack declares a custom doc type? That's XML external entities. That's how you create those funny functions. All right. Which attack uses HTML comments? Injection required those comments. All right. Which one uses the app as a proxy? You get to redirect it someplace so you can do a local port scan and so on. So John E. is one twice, and TT will have to tell me who they are. But Jeff. You're TT? Okay, good. All right. And Jeff, I know who that is. All right. Good. And you're Benson. Okay, so I know who everybody is. Good. So anyway, you got projects to do, although project 16 not yet. And I'll go to the lab and see if anybody wants to work on projects tonight. But let me know if you got any questions. I'm glad to see several people already have an A. That's the way it should be. Because these semesters, midterms is not really in the middle at all. Midterms is more like 3/4 of the way through usually. So if you still have like 0 or something, midterms is a really late time to catch up. But anyway, at least